There is a world beneath our world, a place so remote, so crushingly dark, so utterly hostile to everything we understand about life, that for most of human history we assumed nothing could possibly live there. No sunlight reaches it. The pressure would collapse a submarine like a tin can. The temperature hovers just above freezing for miles in every direction, forever. And yet, down there, in the absolute darkness of the deep ocean, life not only exists, it has existed largely unchanged for hundreds of millions of years. While continents drifted, while asteroids struck, while ice sheets buried entire hemispheres and supervolcanoes poisoned the atmosphere, the creatures of the deep simply continued, quietly, invisibly, completely unbothered. 5 mass extinctions have reshaped life on this planet. Each one killed the majority of species alive at the time. Each one rewrote the story of evolution from near scratch, and each time something in the deep sea barely noticed. How? How does life in the most extreme environment on Earth become the most protected environment on Earth? The answer reaches deeper than the ocean floor itself. A world that never changes. To understand deep-sea survival, you have to first understand what the deep sea actually is. Below roughly 200 meters, sunlight disappears entirely. Below 1,000 meters, you enter what scientists call the midnight zone, a region of permanent, absolute darkness where the pressure exceeds 100 times that of the surface atmosphere. Below 6,000 meters lies the Hadal zone, named after Hades, the Greek underworld. The deepest point on Earth, the Challenger, deep in the Mariana Trench, sits at nearly 11 kilometers below the surface. At that depth, the pressure is over 1,000 times greater than at sea level. A human being would be crushed instantly. An unprotected submarine would implode before it got halfway down. And yet, creatures live there, thrive there, have lived there for so long that their evolutionary history predates most of the life we can see on the surface. Here is the critical thing that makes the deep sea so uniquely survivable across geological time. It doesn't change. Surface environments are chaotic. Temperatures swing, seasons shift. Ice ages transform entire continents. Asteroid impacts vaporize forests and boil shallow seas. But the deep ocean, due to its sheer mass of water above it acting as an insulating buffer, remains, remarkably, almost eerily stable. The temperature in the deep ocean has fluctuated relatively little, even across events that catastrophically disrupted surface climates. When the world above convulses, the world below continues at its slow, cold, unchanging pace. The asteroid that didn't quite reach them when the Chicxulub asteroid struck 66 million years ago, the immediate destruction of the surface world was total. But consider what that impact looked like from the perspective of a creature living 4 kilometers beneath the ocean's surface. The initial shockwave would have registered seismic activity. Of that magnitude sends pressure waves through the entire ocean. Some shallow marine species near the impact zone were certainly killed instantly. The tsunamis that radiated outward from the Yucatan Peninsula were among the largest in Earth's history, devastating coastal ecosystems worldwide. But for the deep sea, the tsunamis are a surface phenomenon. The fires that burned 70% of Earth's forests had no reach below the thermocline. The superheated ejecta that cooked animals alive on land simply could not penetrate kilometers of cold ocean water. The impact winter, the decades of blocked sunlight that starved the surface world, did eventually affect the deep ocean. When photosynthesis collapsed on the surface, the supply of organic material raining down from above, what scientists call marine snow, the continuous slow drift of dead organic particles from surface waters, was dramatically reduced. This was a genuine crisis for deep-sea ecosystems. Food became even scarcer than usual. But here is the thing about deep-sea creatures. They are already adapted to near-starvation conditions. Animals in the deep ocean have evolved metabolisms so efficient, so extraordinarily slow, that they can survive on almost nothing for extraordinary periods of time. Some deep-sea fish have been estimated to live for over 100 years on a food intake that a surface animal would starve on within weeks. When the marine snow slowed, they simply waited. As they always had, as they were built to do, they eat what everything else throws away. Here is one of the most surprising facts about deep-sea survival, one that reframes the entire ecosystem in a single sentence. Deep-sea creatures don't need sunlight because they eat death. Almost every food chain on Earth's surface begins with photosynthesis. Sunlight hits a plant, the plant grows. Something eats the plant, something eats that something. Remove the sunlight, and the entire chain collapses from the bottom up. This is exactly what happened during every major extinction event. The sun was blocked, photosynthesis failed, and the cascading starvation moved up the food chain like a slow wave. But deep-sea food chains were never built on sunlight in the first place. They are built on chemosynthesis, a process where certain bacteria extract energy not from light, but from chemical reactions. Hydrogen sulfide, methane, iron. Compounds seeping up from hydrothermal vents and cold seeps on the ocean floor become the foundation of entire ecosystems that have never required a single photon of solar energy. Hydrothermal vent communities, first discovered only in 1977, which is staggering when you consider how long they've existed, support shrimp, tube worms, crabs, fish, and dozens of other species in complete independence from the surface world. When the asteroid blocked the sun and collapsed surface food chains, these vent ecosystems continued producing energy exactly as they had for hundreds of millions of years before. The extinction was happening. They simply weren't connected to it. Creatures frozen in time. Perhaps the most haunting aspect of deep-sea survival is what it has produced. Animals that evolution itself seems to have forgotten. The frilled shark, a nightmarish serpentine predator with 300 trident-shaped teeth, arranged in 25 rows, has remained virtually unchanged for 80 million years. It hunts in the deep ocean today using the same body plan it used when dinosaurs still walked the surface above it. The goblin shark, with its elongated rostrum and jaw that projects outward to snatch prey, is considered a living fossil, a direct descendant of a lineage stretching back 125 million years. The nautilus, those elegant spiral-shelled cephalopods, has survived all 5 mass extinctions, essentially unchanged. Their lineage stretches back 500 million years, predating even the dinosaurs by an almost incomprehensible margin. These animals are not primitive. They are not evolutionary failures. They are, in the most literal sense, perfected. Their environments changed so little over geological time that evolution had no pressure to modify them. They found a design that worked, and the deep sea preserved it, unchanged, across 500 million years of catastrophe above. The pressure that protects. There is one final, deeply counterintuitive truth about deep-sea survival. The very thing that makes the deep ocean seem so lethal, its crushing, bone-destroying pressure, is part of what has protected its inhabitants for so long. That pressure is a barrier. Almost nothing from the surface can survive the descent. Pathogens, invasive species, the ecological disruptions that spread so rapidly through surface ecosystems, almost none of it penetrates the deep ocean. The same crushing environment that seems incompatible with life is, in fact, an impenetrable fortress wall surrounding it. Deep-sea creatures evolved inside that fortress. They are not surviving despite the pressure. They are surviving because of it. If the hidden, ancient, and genuinely strange corners of natural history are what you're here for, This channel exists for exactly that. Hit subscribe and turn on notifications. We go deep every single week. And drop a comment below. Which deep-sea creature do you think is the most terrifying survivor? We read every single one. See you in the next one.